Now, when dealing with limits, x does not always approach a value. It could approach positive or negative infinity. So before we look at those limits, let's first consider what happens to the function f of x equals 1 over x as x gets really large. Let's consider the fraction 1 over 10,000 or even 1 over a million. If we were to take the limit as x approaches either positive or negative infinity of the function 1 over x, we can visualize as x is getting very large, 10,000, a million, that value is getting smaller and smaller and smaller and is basically approaching 0. So as x gets large, the leading term takes over the graph. For example, when we look at example GA, we want the limit as x approaches negative infinity, and we have a quadratic on top and a cubic on the bottom. But when x gets really large, these other constants, like 5 and negative 12, even negative 8x and negative 4x, becomes insignificant. It is the leading terms that we need to focus on because as x gets really large, they determine what happens to the graph. So the limit of that function would be similar to the limit as x approaches negative infinity of 3x squared over x cubed. If we were to reduce that, it would just be 3 over x. And as x gets really large, this approaches 0. If you want to pause and try B on your own, you can. But the approach is the same. We're going to focus on merely the leading terms. In this case, the variables do reduce, the x cubes, and it leaves us with 4 halves or the number 2. That means this function is approaching 2 as x goes towards infinity. And looking at C, if we were to concentrate on just the leading coefficients, this limit would be similar to the limit as x approaches infinity of x squared over x, which reduces to x. And so as x is going towards infinity, so is our limit. So our limit would be infinity.